Hello students, in this video I am going to teach BRESENHAM's circle drawing algorithm derivation part. The circle can be defined like this. The collection of pixels surrounded from the center point at the same distance. The distance is called radius and we denote the coordinate of the center portion as xc and yc. From the BRESENHAM's line drawing algorithm, we have explicit value for starting point and end point coordinates. Whereas circle, there is no starting point as well as end point. First, we have to choose the starting point. From that, we have to calculate the corresponding pixels. The circle lies anywhere on any quadrant. First, we move the circle from its original location into center. That is, treat the center of the circle as 0, 0, then taking this as the starting point. So this is nothing but 0, radius. Then we have to calculate the next successive pixels from this direction to this direction. But the circle can be divided into 8 equal parts called segments. Each segments are otherwise called octet. So we need not to draw the entire circle. Instead, we have to draw any one octet. Here we are going to draw this particular octet only. Then apply different transformations, we can get the entire circle. So we have to draw this kind of segment only. From this diagram, x coordinate is always incremented and y coordinate is always decremented for next successive calculations. Whereas the straight line, for calculating the next pixels starting from here, both the x and y coordinates are incremented. So before going to derive the circle drawing algorithm, we have to notice some conditions. That is, fix the center as origin, draw only one octet, then finally you can take the remaining 7 octets. So I redrawn this diagram like this. So yk is the radius value. We have to start the circle from here. From this diagram, the important point is the next possible x coordinate value always incremented by 1 and the next possible y coordinate value may be this pixel or this pixel, that is maybe yk or yk minus 1. And the equation of the circle is x square plus y square minus r square equal to 0. So I write the equation of the circle first, that is x square plus y square minus r square. Now I want to find the decision parameter. Decision parameter is represented as pk. Decision parameter find the next possible coordinate value of both the x and y coordinates. So I write like this. So this is the next possible x coordinate value and this is the next possible y coordinate value. Here the next possible x coordinate value is x plus 1. So I write like this. The next possible y coordinate value is either same y coordinate value or the value less than 1 from the previous value, that is yk minus 1. So BRESENHAM takes the midpoint between these two. So in the starting position we have to take the next possible yk values obtained from yk minus 1 by 2. I treat this equation as 2 and apply equation 2 in equation 1. So I treat xk plus 1 as x and yk minus 1 by 2 as y. So I expand this value. So I can get like this. So xk plus 1 whole square plus yk minus 1 by 2 whole square minus r square. So this is decision parameter pk value. So I treat this equation as 3. Then I need to calculate the next decision parameter, that is pk plus 1. So this k plus 1 represents the next possible value. So I replace k plus 1 wherever k is present. So this is the equation for pk plus 1. Then I want to write the complete pk plus 1 value. That is, the next pk plus 1 value always contain the previous decision parameter, that is pk. So next thing I want to do is subtract pk, that is equation 3 from 4. Before that I want to make some modification here so that for achieving simple subtractions, I rewrite this equation like xk plus 1 because xk plus 1 means that is the next possible x coordinate value. The next possible x coordinate value always incremented by 1. So x base k plus 1 is always is equal to xk plus integer value 1. So I rewrite this term as this one. Then I take some separation like this. I treat this term as a first one, that is A, and treat this term as B. So this equation looks like A plus B whole square. So after expand this, I can get this value. That is A square plus B square plus 2 into A and B. The reason for writing like this, the pk value contains xk plus 1 whole square. For subtracting from pk, I want to cancel this term. That's why I am writing like this. I treat this equation as 5. Now I take the pk value. Now I want to subtract pk plus 1, that is 5 minus 3. I rewrite this equation here. Now I want to do subtraction operation. Now I can get pk plus 1 minus pk equal to, this term will be cancelled and r square value also cancelled. Then I rewrite the remaining terms, that is 1 plus 2 into xk plus 1 plus yk plus 1 minus 1 by 2 whole square, then minus yk minus 1 by 2 whole square. I treat this equation as number 6. The next thing I want to do is the minus pk is move from left hand side into right hand side. So before that I want to do some modification here. I concentrate this part only. I expand this term, that is I treat this term as a and this term as b. So this term is looks like a minus b whole square. So I write like this. So yk plus whole square, that is a square plus b square minus 2 into ab. Same way I apply the same formula. So a minus b whole square, a square plus b square minus 2 into ab. So after expanding this, I can get this value. I write this term directly. Then this becomes 1 by 4 and this becomes 2 and 2 cancelled. I can get minus yk plus 1, then minus y square, then this is 1 by 4, that is minus 1 by 4, then minus and minus plus 2 can be cancelled, so I can get plus yk. Then I club the square value first, then yk value next. Finally write the constant value at the end of the equation. So these two terms will be cancelled. So finally I can get this value. Then I group the square value and non-square value like this. So instead of this I can write this value. So I rewrite the pk plus 1 minus pk here. Now I move the minus pk into right hand side. Then I rearrange this equation. First I write the x coordinate value, then I write the y square coordinate value, then yk coordinate value, then finally I write the constant value. Now I move the minus pk into right hand side. So now I can get the equation like this. So this is the final equation for pk plus 1. This is the complete next decision parameter because it contains the previous decision parameter. Up to this, the derivation part of circle drawing algorithm is over. You need to write these steps in your examination. The circle drawing algorithm also contains the 3 important portions. One is initial decision parameter. Then if the decision parameter is negative value, you have to do like this. Then find the next decision parameter. If it is 0 or positive value, you have to do like this. In your examination, the derivation part is over, but you need to understand how this term can be derived from this equation. First I tell how this term can be derived. This is called initial decision parameter. From the circle equation, the initial decision parameter can be write like this. The next coordinate value always 1 because we are taking the starting point as 0, r. Initially, the x coordinate value is 0 only. The next coordinate value always 1 only. So initial decision parameter predict the next coordinate value for the x is 1. In the same way, the y coordinate value may be yk or yk minus 1. BRESENHAM takes the midpoint, so we can subtract 1 by 2 instead of 1. Here, the y coordinate value is radius, so the next possible y coordinate value calculated by r minus 1 by 2. Now I apply the circle equation, that is x square plus y square minus r square formula. So I get this value, that is 1 square plus r minus 1 by 2 whole square minus r square. I expand this equation. So 1 square become 1. Then I write a minus b whole square formula. So a square plus b square minus 2 into r into that is 1 by 2. Then I write the remaining term, that is minus r square. I expand this, I can get this value. So r square is there. Then 1 by 4 minus 2 will be cancelled. So I can get minus r square. So the two r square values can be cancelled. So I can get this value 1 plus 1 by 4 minus r. So I club these two terms, that is 4 into 1, 4 plus 1, that is 5 by 4 minus r. 5 by 4 value is 1.25. After round off, we can get 1 minus r. The next pixel value always integer value, so we truncate the fractional part. So in this way, the initial decision parameter can be calculated 1 minus r only. Next, we will see how this term can be derived. So this is the next decision parameter. I write the next decision parameter equation. If pk is less than 0 means the next possible y coordinate value is this one, that is yk. That means same y value is maintained. So yk plus 1 and yk both are same. Yk plus 1 means not adding integer 1, the next possible y coordinate value. So the next possible y coordinate value also a previous one, that is yk and yk plus 1 both are same value. So this term becomes 0. In the same way, this term also becomes 0. So I remove these two terms, I can get this value. That's why if pk is less than 0, you can get this formula. Now we discuss how this term can be derived. So I write the equation again. It means the next possible y coordinate value is here, that is yk minus 1. It means if yk is 10, yk minus 1 is 9. So the difference between these two terms becomes 1, but this is 9 and this is 10. That is, it gives the minus 1 value. The next possible yk value always lesser than from the previous one. So this terms becomes minus 1. So I write minus 1 here, minus and minus, it becomes plus 1. So this value becomes 2. Now I concentrate this term. This term looks like a square minus b square. I expand this term using that formula. So this becomes a plus b into a minus b. And again, the difference between yk and yk plus 1 always gives the minus 1 value. So I write this term as minus 1. And I want to rewrite this term. Instead of write like this, I can multiply this term into 2 times and add plus 1. I can get the same value. If yk value is 10, then yk plus 1 value always 9. When we add two successive numbers, we can write like this. That means if we multiply the yk value 2 times, we can get 20. Then subtract from 1, we can get this result. Or we can multiply the lesser value 2 times and adding 1, we can get the same value. So instead of adding two successive numbers, we can use either this term or this term. So the successive two numbers can be rewrite like this. Then after this minus 1 multiplication, I can get this value. Then the minus 1 value can be subtracted from 2. So I can get plus 1. So this is the final value for pk plus 1 when pk is greater than or equal to 0. That's why this term can be write like this. But in examination, you need not to explain how this and this and these terms can be derived. But the only understanding purpose, I explained this. In examination, you can derive up to this portion, that is enough. Then finally, you write the circle drawing algorithm. So using this, we can draw the only one octet like this. Then finally, we can get the full circle. Then the circle can be moved its original position. I hope this video helps to understand how the BRESENHAM's circle drawing algorithm formulas can be derived. Thank you.